Now that we've talked about many operators in Project Reactor Flux and Project Reactor Mono classes, let's show how we could implement the async task barrier. I'd shown you the API. We've used it over and over and over again, but I've never really walked through precisely how it works. It's really cool. And now that you know all the operators, you can finally make sense of its implementation. So you can find this in pretty much every one of my projects. We always have an async task barrier because it's used to test out barrier synchronization for asynchronous processing. So we're also going to show how to use it in practice. So the async task barrier API contains a bunch of methods that register, unregister, and run tasks synchronously or asynchronously, depending on what they do. It's geared for asynchrony, but it can also work for synchrony. So it's got these methods, register and unregister, that are passed suppliers to monos, that pass suppliers that return monos to void. These tasks are stored in a list, and it also provides this method that runs all the registered tasks asynchronously. What's returned from run tasks is a mono, which is a reactive type, so it doesn't block. If you want to block, which we usually do, you can, but it doesn't block by default. You could always use it as part of some other reactive collection or something like that. If you combine it with the block method on mono, then of course the calling thread won't go any further until all the asynchronous tasks finish processing, which is the usual use case. So let's see how we might actually apply this thing in practice. So we're now in the IntelliJ project for the EX4 test example. We'll look at the EX4 test example in another video. But for right now, I want to look at the AsyncTaskBarrier tests program. And this program is going to run tests for the AsyncTaskBarrier class. And you can see there's going to be a whole bunch of tests that we're going to run here. And here's the method that tests it. It's called test exceptions. And go ahead and run this guy, and it'll do various interesting things. So you can see these are the results that it gives out. So those are the results. We'll come back and look at them in a second. So here are the various tests we're going to run. We're going to have one test called sync throw exception. And what sync throw exception is going to do is it's going to have a numerator that's non-zero, a denominator that's 0, and then we're of course going to be dividing by 0, which is going to throw an exception. So we want an exception to be thrown. And you notice this is a synchronous call. It doesn't run in a background thread. Then we have another test called async throw exception. And what that does, it does exactly the same thing, except this time it's going to subscribe the operation to run in a background thread. So it's going to go ahead and throw the exception in a background thread. Next, we're going to test these on-error resume operators. And so here's one where we're going to call, trigger an arithmetic exception, and then we'd like to have on-error resume called, but it's not going to be called because there's an on-error continue call downstream, and that's exactly what happens with the async task implementation. And so this actually won't get called. This on-error resume won't get called. We also have another on-error resume test where this time we divide by 0, we call on-error resume, but we use on-error stop. So this time on-error resume will actually be run because there's an on-error continue later. And then we have another test called sync no throw, which completes normally. And we have another one called async no throw, which completes normally and runs in the background thread. All right, so we've got all those different tests. We now come down here and we set up a bunch of suppliers. So we have one called sync throw exceptions, async throw exceptions, and those are just given the method references to those various methods we've just defined. So we have a whole bunch of these method references being stored in local variables. We then register all of these things, so they're now all registered with the async task barrier. We directly register this method, and I'll show you why we distinguish between making these supplier variables versus directly registering them. We then go ahead and run all the tests, and then we check to see what the results are. And only 3 tests should complete successfully. The other one should fail. So this will tell us whether the async task barrier is working properly. And then we remove all but one of the tests by removing the local variables. And the reason we have to do that is that if you use a method reference, it will be a different value each time you use it. Whereas if you use a local variable, that will be the same value, so we can register and unregister them correctly. So now that we've removed a bunch of things, we run the async task barrier. Only one test should run successfully, so we'll get back a return value of 1 if it all worked, and we display the results. So if we go look at the results from this thing, you can see that we got a divide by 0 here in sync throw exception. Sync no throw works. Async throw exception, you can see that that's in a background thread, whereas this is in the foreground thread. Get a divide by 0. And again, notice how on error resume 1 doesn't show up at all because that never got called, because we didn't have an on error stop after on error resume, which was the whole point of that test. And then here's the output of this thing. You can see 3 tests successfully completed. And then down here, removed everybody except async no throw, which ran in the background thread, and 1 test completed successfully. So just kind of demonstrating some of the subtleties involved with all these different mechanisms.